Welcome, everyone. I'm Navati, and I'm the Leadership Fellow of the Mobile Track at Women Who Code. Thank you for joining today's session on 13 tips to write code like a Swiftie. Please welcome our amazing speaker, Mikaela Caron. Mikaela Caron is an iOS engineer at Lickability. She creates content on YouTube, Instagram, Mastodon, and Twitter, sharing her knowledge about iOS development, the daily life of a developer, and freelancing. She freelances part-time building iOS apps and her own indie apps. The first two apps she created were shared on her Instagram story in her story highlights, showing how an app is built from sketch to published on the App Store. She's an organizer for the iOS Dev Happy Hour and loves giving back to the community. Thank you so much, Mikaela, for being here today. I will now pass the session over to you.
Thank you so much, Navati. I'm so happy to be here, and thank you for having me for the Women Who Code. So I'm excited to talk about 13 tips to write code like a Swiftie. So, are you ready? So again, my name is Mikaela Caron. I am an iOS engineer at a company called Lickability. So we make iOS apps, and if you are looking for somebody to make your iOS app, let us know because we make iOS apps and also some other stuff as well, but that's what we specialize in. I am a freelancer for iOS development as well because I just love it so much. I'm an organizer of a monthly online meetup called iOS Dev Happy Hour. This is monthly meetup for iOS developers. It doesn't matter if you are just getting started or you're a seasoned iOS developer, been doing this since the first iPhone OS. Anyone is welcome to join, and it's a monthly virtual meetup too. I'm also a content creator for Twitter, Mastodon, Instagram, and also on YouTube. Much better. Okay, perfect. So let's get started coding like a Swiftie. So what is this? When we're coding like a Swiftie, we're really talking about writing good, clean, readable Swift code. Because that's the whole point of when we're coding. It's easy to write code that computers can understand. It's a lot harder to write code that you can understand 2 weeks later, that your colleagues can understand, and code that you would be happy contributing to an open source project. So you don't want to be coding and then look at yourself 6 months down the road and wonder why you wrote code that way. So our goal with writing Swift code, or any programming language really, is we want to make code that is readable. So this means we want to write code with clarity at the point of use. And we'll go in more in depth with what that exactly means. So we do this by following Swift conventions, and that's what we are going to go through today. Coding like a Swiftie, so we are talking about Swift. So this is Swift the language. Everything we'll talk about is not specific to Swift UI or UIKit, which are the UI frameworks that we use when building iOS apps. So this is all about the actual Swift programming language, and all these tips can be applied no matter the size of the code base. But quick disclaimer though, we are not going to be talking about architecture patterns, unit testing, or anything else like that. This talk is all going to be about the style of your Swift code. So the first tip is using proper casing. So proper casing means capitalizing everything properly with classes, structures, and functions. So we use what is called upper camel case, or just also called Pascal case, for writing protocols, enums, structs, and classes. We use lower camel case, or also just called normal camel case, for variables and parameters, but don't use snake case. So within the Swift programming language, we do not use snake case or kebab case when we're talking about different variables. So what do these look like? So if we were making a protocol called artist, we have the A that is capitalized for artist, the variable name, and that's lowercase. So if we were making a class called pop artist, and that inherits from artist, the P in pop is capitalized and the A in artist is capitalized, so we can read out the word. The variable for name is lowercase, and also the input parameter of name is lowercase. And this goes into when we actually are using this, we have a variable called artist and it is of type pop artist, and we're instantiating a new class. But if we weren't following proper casing, it would start to look something like this. So if we broke this down, we have a protocol called artist, and we ended up capitalizing the end in name, or the N in name. It doesn't look too bad, but then now we create pop artist, that's a class, and if we don't capitalize the P in pop or the A in artist, it doesn't look too awful to read. You can still read it because pop, is only 3 letters. But then we capitalize the N in name for that variable, so now it's self.name is equal to name, but you have to remember that the N in name was capitalized. But the issue really becomes at the point of use. So we have a variable, let Taylor Swift. This kind of looks right because we're capitalized the T and S for Taylor Swift. But now when we look at how we're instantiating this, pop artist now is starting to look like a function more so than a class instantiation. So when we're expecting to see a certain casing and we're not seeing that casing, now it's kind of confusing when you're reading the code what you're actually looking at just because of the casing, even though the code is completely valid. Tip number 2 is about naming. So in Swift, we use US English spelling. We prefer function names that make the call site read like natural language, and we'll go more in depth with what that means. Booleans should read as assertions about the receiver, and we'll talk about that. Protocols that describe capability should be named with suffixes that start with or that end with able, ibel, or ing. And all else should be read as nouns. So let's break all this down. We want to use US English spelling. So this is when we have an enum, for example, called album color. The spelling for color does not have a U in it. And then same thing if we had a function called make favorite, there's no U in favorite. We prefer functions that make the call site read like natural language. So what that looks like is we have a function called compose song, and it takes an input parameter called lyrics, and it's just returning the lyrics with 2 music notes around it. But it's the clarity at the point of use of when we are actually calling our function. This function would read out compose song lyrics, and that makes sense. That's like an English sentence. Or Booleans should read as assertions about the receiver. So this means if we have a Boolean variable called are you ready, this makes a Boolean is true or false. This makes sense of are you ready? That is a yes or no answer. And then we have another one, are we getting back together? Again, this makes it easy about the assertion about the receiver, so we are asking a question. So when you're reading this variable or talking about it with other people, it makes sense of this would be true or false, and it's easy to know this is a Boolean variable. And then we can also do this with functions. So we have a function called isEndgame. It's again a yes or no answer, so that means it's something that is true or false. Protocols that describe capability should be named with the suffixes able, ibel, or ing. So this would look like a protocol called callable, and then a protocol called lovable. Excuse me. These are protocols that have a capability. So what it's able to do is, can you calm something, or is something lovable? And then lastly, we also have equatable. So it's a normal protocol in Swift. Then everything else should be read as nouns. So we have a variable called artist. Artist is a noun. And then also we have a variable called lyric. And then again, lyric is a noun. Tip number 3 is argument labels. This is syntax that adds a word to make a function easier to read. So it would look like this. We have a function called is there an I. In is the argument label, and then an input parameter called word. So it's again the clarity at the point of use. So if when we call this function, it would look like this. Is there an I in team? So it's really easy to read this function, and the whole point is to make the function easier to read at the call site, at the point of use. And think about it when you're talking with other people. When you're describing code between your coworkers, you can say, oh, we're talking about the function, is there an I in team? Or is there an I in some kind of thing? If we didn't have this argument label, it would look like this. It would just say at the point of use, is there an I word? And that doesn't really form an actual sentence. So that's the whole point of an argument label. It's to make the function easier to read. Tip number 4 is about type alias. So a type alias introduces an alias of an existing type. So think of it like you have an alter ego, and we have an existing type that is fully valid, but we want to call it something else. So for example, you can do this. You can make a type alias of color, spelling it not the US English spelling, and make it a type alias of the color spelling without the U, but don't do this. You can, but don't do it. But more realistic examples are a type alias called OS status is a type alias for an int 32. So instead of returning instead of returning int 32 from something, we can return OS status. And then if anyone didn't know, the type alias of codable is a type alias of decodable and encodable put together. And another better example is, say we make a type alias for discography, and the actual type is an ordered dictionary with a string as the key, and the value is an array of songs. So instead of always typing out ordered dictionary string array of songs, we can instead just type discography. So when we use that in a function, we have make Taylor discography that takes in an input parameter of discography as opposed to typing out that entire type. And that's where it becomes really useful, because now it's much easier to read what's happening as opposed to always reading ordered dictionary string array of songs. Tip number 5 is about documentation. So we want to write a documentation comment for every declaration. And this is what Apple's guidelines actually say. Whether you follow it or not is up to you, but the goal is to write documentation for every declaration. So if you do, you can use 3 slashes before a function, and it would look like this, where you have creates a string with surrounding music notes, you have a parameter called lyric, and then what it returns. But the real power for this is when you use it, when you hold Option and click on that function name, now our entire documentation has turned into what's called the quick help in Xcode. So we can easily see the summary of creates a string with surrounding music notes. We see what the function declaration is, and then we also see what the parameters and return values is, just how we wrote that documentation comment. So we can use the quick help at any point of when we're using any kind of function, that's a lot easier, rather than having to go to the actual function definition to see what's happening. Tip number 6 is about access control. So it's all about what objects can access other objects. Because when you think about it, bugs are from one object accessing a different object that it shouldn't be able to and changing its value. That's really what a bug is. So we can prevent some of that by using access control. And we do that by trying to make default to private and get only variables. So for example, we have a class called Taylor Swift, and we make the variable lyrics, we set it to a private set variable. And then we have the normal initializer. So what this looks like is we make a new variable called Taylor, and it's of type Taylor Swift, and we have the lyrics, I just want to stay in that lavender haze. If we print out Taylor.lyrics, we would get, I just want to stay in that lavender haze, like we would expect. But if we tried to change Taylor.lyrics to I'm the problem, it's me, we see that print Taylor Swift.lyrics, that part is correct. But if we tried to do this with our private set variable, we would get the error, cannot assign property lyrics, setter is inaccessible, which is the point. It's we can no longer change these lyrics from outside of the function. So I know what you're thinking. You need to calm down. It's okay. We are halfway through the presentation. Be glad I didn't choose 22 tips. So tip number 7 is about code structure. This is all about how a file is organized. And we're not talking about the file navigator on the far left of Xcode, about where you put files in folders. No, we are talking about how we organize our actual code in a Swift file. So we want to follow this structure. We have import statements at the top, then we have protocols, we have a main type declaration of that file, we will then have properties, methods, and then at the bottom is extension to protocol conformances. So when we look at this is useful for a few reasons. So this is called the jump bar in Xcode, or it's also, I think, called document items is what it's really called. And if you navigate to it from like the view editor and then show document items, it would look like this. And we can see when a file is nicely organized, we see the class at the top, we see all the different properties, we see some methods, and then at the bottom, we see cache and an extension to some kind of protocol. So we know where we're going when we organize everything in a proper way. So this is also useful when we are using the minimap. So this is, if you turn it on the right side of Xcode, you would see the minimap. So you have a reasonable expectation of where you're looking for something. So if you're looking for a property definition, you would see it at the top. And then also, if you're in the minimap and you hold Command, you would then see this, which shows you, again, all of those declarations of methods and of methods and variables in the minimap as well. And then you can click on these and go directly to them. So the real power of this is having everything organized where you would expect it to be. So if you didn't follow this and then we're looking at the jump bar, you would start to think, okay, the very top is some kind of extension. Is that what this file is about? And then you later see, oh no, it's actually a class called timeline view model. Oh, is that what this file is actually about? So you see then a method, then you see a couple variables, but then another method. So if you didn't organize everything in the proper way, it's a lot harder to find what you're looking for because you would spend more time scrolling up and down just in this file to look for some specific definition. Tip number 8 is about enumerations or enums. So Apple defines this as defines a common type for a group of related values and enables you to work with those values in a type-safe way within your code. So Swift is a type-safe language, meaning, and is also statically typed. So that means everything, is defined a certain way, and you can't switch types of variables. So this would look like if we had an enum called album with these 3 different cases of reputation, midnights, and evermore. This is a normal enum, but the real power of enums comes from different things that we can do with it. Enums have what are called raw values and associative values. So if we looked at a raw value of the enum example that we had before, we added an integer to this enum, and this lets us add an integer to every single one of these types. So we have an enum, the case reputation has the value 2017 next to it, midnights is 2022, and evermore has 2020. And a raw value means we're just really like tacking on a value with our enum case. And notice it's always the same type. So all of these are integers, as opposed to the other way of using enums is using an associated value. So here you can see reputation has an associated value that's an integer, and then midnights has associated value of a string. And you can see we can tack on an associated value of 2 different types rather than having to always use the same type. So when you use this enum, every time you use it, you can pass a different value to that specific case. So this becomes really powerful with enums. So here's a more concrete example of we're creating an enum called a song request, and this is like a network request. We have 2 different cases of my songs and request song, and then request song has an associated value of a ID that's a string. The first thing we have is base URL, which is a computer property, and it actually returns api.url, which could be another enum. And then we would make, let's say, another computer property that's the path. So we can actually switch on the enum itself. So for the case of my songs, we can return the endpoint /my songs. And for the case of request song, we pass in that ID parameter, and we can now make the endpoint of /request/ID. And then same thing with enums like this, we can make a computer property called HTTP method, and the type is also HTTP method, which could be another enum. We can again switch on self, and now when we return each different case, we have return a .get request or a .post request. And now that we've created this enum with these different computer properties, when we actually use it in our code with some kind of, say, network controller, we make a network controller and with a send function that takes in our enum. So our request looks like song request dot request song ID and then pass in the song ID. And this allows us to make the network request. Everything is handled in the controller, and it already has all the information that it needs to properly make that request, and we don't have to define anything else because we already did all of that within that enum. Tip number 9 is formatting large numbers. So the whole point of this is to improve the readability using underscores. So this is the only time you would really use underscores with variables. So it could look something like this. We have a structure called statistics, and it has a variable called views. And then we create a type of shake it off stats. And when we input the value, we can use underscores to separate this number just to make it easier to read. So we have 3,278,311,534. And it's a lot easier now to read this number as opposed to before. If we didn't have any underscores, this number would be much harder to read. And then same with all the others. And a fun fact is you can actually put the underscore anywhere within the number. I put it every 3 digits because that's in like US English how we typically separate numbers, but you can actually put the underscore wherever you would like. Tip number 10 is about blank space. So we're talking about vertical and horizontal spacing. So if we had a struct called lyric, and we have a couple variables and a function in here, this code is completely valid, but there's a lot of unnecessary vertical white space, and Swift doesn't really care about this white space, but as programmers, it's a lot harder to read this code. So this is a small sample of like only 4 variables and 1 function, but imagine if an entire file looked like this. You would be scrolling up and down constantly just to look at different variables and function declarations. And it would be really hard to start understanding how something is working when you're constantly scrolling up and down. But then also, you could have inconsistent horizontal spacing. So again, this code is completely valid, but the spacing horizontally is very confusing because it's hard to connect certain things from one to the other just because the horizontal spacing is kind of breaking up how you're trying to read this code, even though it is still completely valid. But then if you combine both of these together, your whole file could start looking like this, where you have vertical spacing that's all inconsistent, and then horizontal spacing that's inconsistent, like the function is pushed over to the right too much, variables are at different levels, and then also the spacing between like the equal sign and everything. The code would just be very difficult to read. So when we look at Swift code, this is an example of what this struct should properly look like. We have 1 space between the actual type and then the first curly brace. There is 1 space between the colon and then the type for some kind of variable. There is 1 space on each side of the equal sign, so between the type and then the actual value. We have 1 space between the parenthesis and the first curly brace for a function. And then here, the 2 curly braces that end the structure are also on a new line. And then you can see at the very beginning, it's the struct lyric. The first curly brace is on the same line as that type, and we don't put it on a new line, because that's more of a convention of languages like C#. Tip number 11 is don't use prefixes. So we want to avoid general prefixes before types. So that would look like we have a struct called tsLyric and then a bunch of variables in this structure. So the prefix that we want to avoid is having this ts. So this was previously required in code like Objective-C, where when we would use third-party code, the third-party code could clash with our own code. So because of that, we previously had to use a prefix, but now that we write Swift, we don't have to do that anymore. So you can see we just take off the ts and we just have a struct called lyric. And this also helps with autocomplete, because if you start typing some new type in your code and you start typing ts, everything would start with ts, so it defeats the point of autocomplete when you use that prefix. So that's why we have taken it away, and it's better now in Swift that we don't have to do that. And this goes with tip number 12 about namespacing. So namespacing is all about grouping related items. So we can use nested types to accomplish this, and it prevents name collisions, like we said in the last tip. This could look something like this: an enum called design, and inside of that we have an enum called grid, and then we have 4 different properties for, say, sizes that we make for like padding within our application. So this is nested because when we actually go to use it, we have design.grid.medium. And the only way to actually access grid is we have to go through the design. So we can't really use grid anywhere else within our code alone. We have to use it with design. And this also gives you like better scoping and helps you understand how everything works. So with all these tips, you're thinking, how do we keep everybody in sync with all of this? So that's where we have tip number 13, which is using SwiftLint. So SwiftLint is a tool to enforce Swift style and conventions, and it's an open source project by Realm. So what this does is we enforce the Swift style and conventions by making what is called like a rules file. So it would look something like this. SwiftLint lets us add Xcode warnings when you break some of the rules that we define. So for example, if you're breaking the vertical spacing rule, we can see a warning in Xcode that shows you vertical whitespace violation. Limit vertical whitespace to a single empty line, and currently you have 3. So this immediately prevents you from violating some of these rules. We can make warnings in Xcode, but then we can also make errors as well, if it's something you really want to enforce and make sure that nobody does. So I know this sounds kind of boring, but that's okay. It's when you think about it, the whole point of why we're writing code and why we're programming is we want to make something happen, but if we want to maintain that code, then we have to make code that ourselves can read, that our coworkers can read, or if you want to contribute to an open source project, it has to be code that others can read as well, not just the computer. So these are the 13 tips that we went through today. So just take a minute to think about each one of them. And which one do you think that you'll use the next time you sit down with Xcode? So when you sit down with Xcode the next time, you too could be writing code like a Swiftie. Thank you. Are there any questions? Oh, I totally did not think that my picture was in that QR code.
Thank you so much, Mikaela, for presenting those amazing Swiftie tips. It was definitely a Swiftable session, and we learned so much. So folks, please feel free to share any questions you have for Mikaela in the chat. And in the meantime, here is a question for you. Are these principles more applicable to Swift UI or UIKit?
So this does not matter if it's Swift UI or UIKit, which is the best thing is that this is about the language itself, so it doesn't matter if you're using whichever one. All of these tips apply.
Makes sense. And yeah, definitely applies to even other languages. So I really love that. I know some Android folks who are also tuning in and absolutely loving your session. Here's another comment that you just saw there. Yeah, it was really, really good and loved the puns. That was really awesome.
Thank you. I've been listening to Taylor Swift constantly for the last like 2 weeks, so all of my YouTube suggestions are Taylor Swift.
Amazing. Yeah, and I love that you called an alias an alter ego. I thought that was
Mhm.
really a nice way to think about it. But do you ever feel that having a type alias can be overused sometimes? Do you have any tips around it if you think so?
Yeah, type aliases could definitely be overused because you then have to start thinking about what this new type means. If it's some type specific to that code base, it may be harder to read. But if you properly document your code and then you can use the option click to click on the quick help, then you can immediately see what that type means at the point of when you're using it. So it's a lot easier to start understanding how they work versus if your code was not documented in that way too, then you would have to go back to the type declaration, hope that it makes sense wherever they wrote the type alias. So that's where it helps documenting the code along with using, yeah, type alias.
Yeah, that makes sense. And one tip that I like was the use of mini maps because that's something I usually just see, but I haven't really tried using it. So I think that was really clever. If you have anything else that you want to add to, what we could do with mini maps, I'd love to know.
Yeah, it's the option click is super nice because you sometimes find that on accident that you could do that. It's I know I've accidentally clicked on it, but if you hold option or sorry, if you hold command and click on the mini map, it's you can then like kind of quickly scroll through and see those types. So if you're like sometimes 500 lines down in a single file, then you're trying to find some kind of variable, you can quickly use the mini map to see where that variable is actually defined and then get to it a lot easier, as opposed to that goes also with the code structure is when you're looking through a file, if you know where you're expecting to see some kind of function too, it's easier to find it. So that's why the mini map helps along with structuring your code properly too.
Yeah, that's awesome. Yeah, it could really help with searching too, right? Like when you're searching for some text and you scroll, and yeah, that makes a lot of sense. I'm going to try that next. Yeah, thanks for that. And is there any other tip that you feel is often overlooked? Something that you wish more developers knew or followed?
Ooh, that I wish more developers knew and followed, especially, I would almost say it would be the vertical and horizontal spacing, because that's something I see with a lot of beginners. Swift is not a white space like agnostic language, so the white space doesn't matter as like to the computer, but as a person reading somebody else's code, that's where it really does matter because you'll see like a view will be tabbed over like 4 times, and then the variables are like left aligned and all sorts of stuff. So it's a lot harder to read that when you're trying to understand somebody's code base. If it has inconsistent vertical and horizontal spacing, it's something as like a more seasoned programmer you immediately notice in a new person's code when they're just learning. Just because nobody in tutorials actually tells you, hey, you should align the code this way. They just kind of do it, but when you're still learning, you kind of accidentally are deleting things all the time and you end up having inconsistent spacing. So one way to fix that too is you can select all the code with like Command A and then use the shortcut Control I, and that will re-indent your code properly with the next code.
Yeah, and that's a great tip on just being just having your code look more professional, even in coding interviews. Um, yeah, so there's a question from Nancy. Would For inconsistent blank space, wouldn't your linter complain? I'm used to Ruby on Rails, and Rubocop would complain for sure.
Yes, exactly. So we have SwiftLint is the main linter that a lot of Swift developers use, and that is an open source project by Realm, which is owned by MongoDB, if anybody's heard of that company as well. So yes, that is the whole point of using SwiftLint is to fix smaller things like line spacing, but a lot of beginners don't end up knowing how to do that, so we don't have a linter built into Xcode. We're right before WWDC. Maybe that could happen, probably not, but that's the whole point of, yeah, we have a linter as well that uses that, but it all depends on how it's set up in the project because in what rules people define as well.
Awesome. There's another question here. Can you help on type alias and argument labels?
Yeah, so a type alias, you'll really use it for, I would say the example that I gave with the discography would be one of the best use cases because the type itself was called ordered dictionary, string, and then array of songs. So instead of having to type that out every time you use it, you would just make a type alias for discography. So anytime you want to use that really long type, instead you would use your type alias. And then with argument labels, those are really to make the code more readable. So I've made functions that are like present alert on view controller. So on is that argument label. So when you are actually writing the function, it says uh, make alert like on view controller, and that's how it's like said out loud. But the argument label makes it easier. Otherwise, it would have said make alert view controller. So it's that almost sounds like, are you making a new view controller that's an alert, or how that kind of works? So the whole point of having an argument label is to make the code easier to read at the point of when you're using it. So when you're actually calling that function. And you can look at Apple's API design guidelines. I can link that in the chat, and that's where they like two-thirds of that page is literally about like naming. So I'll link that in the chat to make it easier as well.
Yeah. Yeah, I love that. I love the naming conventions and protocols, and yeah, especially how your examples were also amazing. Yeah. So thank you so much again, Mikaela, and thank you everyone for sharing your amazing questions and your comments. Mikaela, thank you again for your time today and your excellent talk. And yeah, thank you folks for joining the session and being a spectacular audience. We are getting ready to start our next session. Please join that. And during the summit, also be sure to check the one-to-one networking feature and our expo. We have so many amazing things happening throughout the summit, and I hope everyone enjoys the rest of your time at the Women Who Code Dev Summit Mobile and Web 2023. Thank you.
Thank you so much.